Internal combustion engines are fascinating machines that power a vast array of vehicles and equipment. Engines come in various types, each with its own cylinder configuration. Internal combustion engines generate power by burning fuel inside a combustion chamber. The most common fuels used are gasoline, diesel, and natural gas. Let's begin with several key components, meticulously engineered to convert fuel into mechanical energy. At the heart of these engines lies the piston, a cylindrical component housed within a cylinder. Connected to a crankshaft via connecting rods, the piston's reciprocating motion drives the engine's rotation, translating combustion force into usable power. Surrounding the piston is the cylinder, a chamber where combustion occurs. Valves, including intake and exhaust valves, regulate the flow of air and fuel into the combustion chamber and the expulsion of exhaust gases. The camshaft synchronizes valve operation with piston movement, ensuring precise timing. The ignition system, comprising spark plugs or glow plugs, initiates combustion in gasoline and diesel engines, respectively. Fuel delivery systems, such as fuel injectors, atomize and deliver fuel into the combustion chamber. Essential for engine longevity, cooling systems circulate coolant to dissipate heat, while lubrication systems ensure smooth operation by reducing friction and wear. These components work in harmony, orchestrating the controlled explosions that propel vehicles and machinery forward while minimizing emissions and maximizing efficiency. Internal combustion engines operate on what's known as the four-stroke cycle, also called the Otto cycle. It consists of four distinct stages: intake, compression, power, and exhaust. Intake stroke. The piston moves downward, creating a vacuum that draws a mixture of air and fuel into the combustion chamber through intake valves. Compression stroke. The piston moves upward, compressing the air-fuel mixture inside the combustion chamber, increasing its pressure and temperature. Power stroke. At the top of the compression stroke, a spark plug ignites the compressed air-fuel mixture, causing a controlled explosion. This rapid expansion of gases pushes the piston down with great force, generating power. Exhaust stroke. The piston moves upward again, expelling the burned gases from the combustion chamber through exhaust valves. There are several common types of engine configurations such as V-twin, inline 4, V6, boxer twin, and many more. But the basics of its operation are still the same as this single-cylinder engine. Understanding these basic principles gives insight into how engines work, though the actual operation can be more complex, especially in modern engines with advanced technologies like turbocharging, variable valve timing, and direct fuel injection. And that's a wrap on today's video. I hope you enjoyed learning about how internal combustion engines work. If you find this video helpful, don't forget to give it a thumbs up and hit the subscribe button below for more content like this. For more learning videos, check out our playlist, and remember, your feedback means the world to us, so leave a comment below with your thoughts or any questions you may have. Thank you, and see you in the next video.